All right, let's just jump right in. Today, we're breaking down a pretty dense and formal report that just came out of the US Department of Energy. And what's interesting is that it offers a scientific perspective that, frankly, pushes back on a lot of the common narratives we hear about climate. So, we're going to walk through its core arguments piece by piece.
Right from the jump, the forward throws this line at you. This quote is really the key to the whole document. It's signaling that the goal here isn't to deny that the climate is changing, but to completely reframe how severe we should consider it. This one sentence, it's the lens for everything that follows.
So, where does a report like this even begin? You might think it'd start with rising temperatures, right? But no, it starts with a really fundamental re-examination of carbon dioxide itself. The authors are basically saying, hold on, before we even talk about its effects, let's get on the same page about what CO2 is from a scientific standpoint. So the report kicks things off by drawing a really bright line in the sand. On one side, you have what are called criteria air contaminants. Think of things like soot and sulfur dioxide that create smog and are directly harmful. On the other side, they place CO2, pointing out that it's odorless, non-toxic at normal levels, and, absolutely essential for every plant on Earth to live. This distinction is the bedrock of their entire argument. And building right on that idea, the report presents what it calls a major positive effect of CO2. It points to satellite data that shows huge portions of the Earth, between a quarter and a half of the planet's vegetated land, have actually gotten greener over the last few decades. The report's claim is that a whopping 70% of this global greening is a direct result of more CO2 acting like a fertilizer in the atmosphere. Okay, so if that's the report's take on CO2's direct impact, what about its view on how we predict the future? Well, that brings us to the second major part of this thing, a deep dive critique of the climate models themselves. And this right here is the million-dollar question for this whole section. It's not just about what a model says will happen in 2100. It's about looking backward and asking, how have these models performed so far when you stack them up against what actually happened in the real world? Let's see what they found. Before we get to the charts, we have got to wrap our heads around this key term, equilibrium climate sensitivity, or ECS. It sounds complicated, but it's basically just the model's best guess for how much warmer the planet will get if CO2 levels double. And the point the report hammers home is that the latest, most advanced models, well, they don't agree. The range of possibilities goes from a pretty mild 1.8 degrees Celsius all the way up to a really high 5.7 degrees. That's a huge amount of uncertainty. So here's the first big data comparison the report makes. That bar on the left represents the models that have a high ECS. They predict a lot of warming. The bar on the right, that's what we've actually measured. According to the report, you can see a pretty significant gap. It suggests that these high-sensitivity models have, so far, predicted more warming than has actually occurred. And this isn't just a ground-level thing, according to the report. If you look higher up in the troposphere, that's the lower part of the atmosphere, you see the same story. This chart shows the average of the climate models predicting more warming than our satellites and weather balloons have actually picked up. The report's phrase for this is that the models are running. Now, to make this even more concrete, the report zooms in on a really specific and important region, the U.S. Corn Belt. And the analysis here is pretty stark. It compares the model average for summer warming against the trend that's actually been recorded over the last 50 years. It states that all 36 models they analyzed predict a faster rate of warming for that region than what the thermometers have shown. All right, so after questioning the models we use to predict the future, the report then hits the rewind button to look at the past. It asks a simple question. What does the long-term, real-world historical data tell us about extreme weather trends right here in the U.S.? For tornadoes, the report presents a finding that really cuts against the grain. Citing data directly from NOAA, it shows that the frequency of the most powerful and violent storms, we're talking the big ones, EF3 to EF5, has actually seen a major decrease of about 50% since the 1950s. And this isn't just about tornadoes. The report applies that same historical microscope to other events. For hurricanes making landfall in the U.S., it finds no significant trend going all the way back to the 1920s. For flooding and droughts, it says the data just doesn't support the idea of a worsening trend, and that the Dust Bowl of the 1930s is still by far the worst drought benchmark in American history. So you might be wondering, why do these findings seem so different from what I usually hear? Well, the report suggests a big reason is that we often look at data over too short a time frame. It uses this wild example of the Nile River, which historical records show had a massive, natural drought that lasted for centuries. The point is that nature itself has these huge, long-term swings. And if you don't have that long-term perspective, it's really easy to mistake a natural cycle for a new man-made trend.
This brings us to the final section, and this is really where the rubber meets the road. The report takes all this science and data we've been talking about and translates it into the one language everybody understands: dollars and cents. It's an attempt to weigh the cost of warming against the cost of our policies.
To do this, they have to use this key metric called the social cost of carbon, or SCC. Just think of it as an official estimate of the total price tag of all future damages to health, to agriculture, you name it, caused by emitting just one more ton of CO2 into the air today. It's a hugely influential number in policymaking. So check out this table from the report's economic modeling. It compares two scenarios. The first, which it calls the optimal policy, results in 3.5 degrees of warming and has a total projected cost of about $135 trillion. But the second, more aggressive path, which targets just 2.5 degrees of warming, sees that total cost balloon to nearly $178 trillion. And here is the bottom line of their whole economic argument. According to this analysis, trying to hit that tougher 2.5-degree target would actually cost the global economy over $43 trillion more than the path they call optimal. So the argument they're making is a big one, that the economic damage from such an aggressive policy could actually be far greater than the climate damage it's trying to prevent.
Okay, so let's just quickly recap the four central pillars of this report. 1, it argues that CO2 has major, tangible benefits for plant life, the whole global greening thing. 2, it claims that our main climate models consistently run hot, over-predicting warming compared to what's been observed. 3, its analysis of long-term U.S. data finds no significant worsening trends for most types of extreme weather. And 4, its economic models conclude that super aggressive climate policies might end up being more costly than the warming they're designed to stop.
And this quote from the very end of the report really sums it all up. It's not a call to do nothing. It's a call for a different kind of approach, one they describe as more nuanced, that looks at all the evidence and, crucially, isn't afraid to admit how much uncertainty is still involved in all of this. And so, we're left with the fundamental challenge this report puts on the table. It is a massive, complicated balancing act. Given the scientific uncertainties and the huge economic trade-offs it presents, how should we as a society balance the very real risks from a changing climate with the equally real need for energy that is reliable and affordable for everyone? That's the critical question this report leaves us to wrestle with.